Alright, so today I wanted to give an overview of how I wired up my house and some of the common codes, as well as some more advanced things that I like to do with my installs that I don't see very often. I had a house fire about 6 years ago where a power line was actually dropped on my house right up here, and it caught the garage portion on fire. It was only a 10 by 10 area, but it basically energized and burned out everywhere in the house, so I ended up having to go in and rewire it. I am an electrician, so I ended up taking on that portion of the job myself just because I like my work a lot better than some of the work that I see out there. And I just wanted to show off a little bit of my work and some of the things I like to do to just improve a system, most of which are actually not that much more expensive than a standard, but it does add a lot of nice features and things that most people don't think about when they wire up their house. Starting out here, you can see my main service coming in is underground, and that is coming into this disconnect. Typically, SRP, who's out here, or APS, requires you to use or wants you to use one of their panels. So all your breakers would be out here, your main service would be out here, your meter socket would be out here. I decided to go with a UL listed main service disconnect. So there is a 200 amp disconnect that you can see right here, which meets requirements. And then you will see my meter here. Something that you will not typically see, and I have yet to see on any other home on the thousands of homes I've worked on, is surge protection for the main feed coming into the home. So you'll see this device that goes in between the meter and here, and that is to protect main surges going into the home from any number of different things. Since it was only a few $100 and pretty easy to install, I decided to get one and install it. I didn't realize, with SRP at least, they were going to throw a little bit of a fit about that because they consider that their side of the system. And I said, well, how do you protect your service in case of a surge on the line to protect everything prior to the panel? And their answer was basically that they offered it at one point, but they no longer offer it, and they don't allow you to do it yourself. So I went back and forth for quite a while and ended up getting them to cave in. Same thing with the meter out here. I finally got them to approve going in with just a 200 amp disconnect instead of one of their panels because, like I said, it meets all current codes. They just didn't like it for whatever rules and things that they liked. But it is 100% safe and legal to be able to do. So I've got all that. Now coming down here, you will see that I've got two other boxes here. Right here, the smaller one, that is actually a box that holds all my grounds for my communication stuff. So that's going to be for Cox, CenturyLink, DirecTV, any of those type of providers. Each require their own separate ground anytime you're entering into a new system. So that is the junction point for all that. I'm not going to open it up just because it is sealed up, but I will show you it on my sub panel that I have in the shop. Over here, this is where I have all my feeds going in from here to my low voltage panel in the main house. So I've got a disconnect here, and then in my garage I have the actual sub panel for all my connections. A lot of people will ask, well, why would you take the extra time and money to do that? And the simple answer is arc fault and other type of breakers, especially when you have large loads all at once, will sometimes cause it to falsely pop the breaker. I've seen this multiple times where I will run specific power tools or even kitchen appliances, and it'll trip the arc breaker by mistake, and then you have to reset it, and I just don't want to go outside to have to do that. So the nice thing is it's in the garage where it's nice and easy to get to. Without going into the garage, I'm not going to show you that, but I will show you pretty much the same type of setup I have over here in the shop. So while I had everything open I had planned on building this large shop at some point, but in the meantime I had just a Weather King shed that was a 12 by 32, and I ran oversized power for building this because I knew at some point I was going to build this shop. So I had the main feeder run through the attic, down the wall, and you can see it comes out to a disconnecting switch right here. You are required to have a means of disconnect, so this is it. There are two fusible links in here as well. and you can see there's an on and off position, and then I have a conduit that comes down from there and then underground and then over here into the main shop. So we will go ahead and come in here now, and you will see the feeder pipe that comes up through my footer and then into the panel. You will also see that I had to heat up the pipe a little bit just to offset it enough to match up with where I wanted the panel. I am doing 5/8 rock plus some hardboard, so I do have this furred out just a little bit. All panels do have a little bit of spring to them. You are supposed to mount that flush with your existing wall. It also gives you more room for some of the punch outs to run your feeders by having it flush, but since I do have an extreme amount of wall material, I decided to fur that out just a little bit to be able to do that. Something else to keep in mind before you install your panel, at least for efficiency, as well as just keeping your electrical cool, you'll see that back behind here, I actually put in a piece of foam. This is 2-inch foam since this is a 2x6 wall, and with that furring out, it gives me just that extra little bit of insulation to help keep my electrical cool, as well as the shop in general. Anytime you can pre-plan and pre-put things like this in, it just improves the overall envelope of your structure. Now coming over here, you will see this is the U for ground. So I've got a separate ground that's coming up through here. Although I call it U for ground, it also is a standard ground. It is bonded to my my rebar like a U for ground, but I have a full 30 foot of wire plus 2 ground rods, you know, spaced 10 feet apart, bonded, all that other good stuff, just as extra measure. It's way overkill, not necessary. If you like a video on how to do proper grounding and the different methods of grounding, I'd be more than happy to show that in one of my job sites where I'm actually doing this. As I've said before, I am an electrician. You know, I do this for a living, so I'd be more than happy to show some other examples and some of the other jobs that I've done in the future or in the past. All right, coming out of here, you can see our feeder wires. One of the things I don't like seeing, you see a lot with homeowners, and it's more of a convenience factor for doing the install for the feeders versus anything that is code related. Anytime I have a feeder coming in on one side of the panel, I like to terminate it on the other side of the panel, and that just gives you extra wire, a little bit more flexibility in the wire to make it easier to make your termination contacts and so forth. I have had times where I've had to do a panel change out where I've had the feeder come in, let's say from the top, and they're adamant that they want the main breaker at the top, and there's no getting around it, and it's just a pain in the butt to try to force big heavy gauge wires into the terminals. It just kind of sucks. If you can avoid it, great. If you can't, you know, have fun. Now, going back to the terminations, you will see each of the terminations have dielectric grease in there. That is a requirement anytime you have the main feeder lugs to put dielectric grease in, especially if it's aluminum or dissimilar metals. You want to have that dielectric grease just to prevent corrosion. Also, after you've gone through and energized things, it's always good, you know, after you've torqued it the first time, come back later, torque it again, make sure nothing's loosened up at all. Just as a good thing to keep from arcing and damage. I have seen multiple times that other installers have gone in, finished out, either didn't fully torque down or forgot to torque down something, and it's caused damage to the system in one way or the other, or just intermittent problems. So just something to keep in mind. You'll also see that I've got caps. There are caps that are included with most panels now, and they do have replacements for these. A lot of times they don't get installed, they get tossed, they get forgotten, whatever, and that is required to be protected on your 2 hots that are coming in. You'll notice that we have a black and a red, those are your hots, and the one with the white stripe is your neutral. The bare wire is your ground, and that is going to be coming up through here and bonded to the grounding block. And you can see that U for ground is coming up, and I have it going between here and here. It's not required to have it span both grounding bars, but since I had the wire and it doesn't hurt to have, you know, extra connections, I just went ahead and did that. You will also notice that I have separate grounds for each of the grounds. Now, depending on the manufacturer, you can sometimes put in 2 grounds per line. or per post, but that is per manufacturer, but that is only on the ground, not on the neutrals. The neutrals have to have their own. Something else you'll see is the grounds and the neutrals are separated in this panel. This is a sub panel. Anything that is a sub panel that does not have the meter, essentially, if there's a meter on it, that is a primary panel. If it doesn't have a meter, that is a sub panel, regardless of if all your breakers are in the sub panel and you just have a primary means of disconnect like I do, you still have to treat it like a sub panel. So you'll see my neutrals are up here, grounds are down here, and separated. Something else to keep in mind, for those who are aware, you will notice that I do not have any GFI protected breakers down here. The reason for that, in my area, I am still under 2017 code, even though this is 24, and they're just way more expensive and have potential for issues, and I just didn't want to put it in here for things like ranges or other devices like that in the future codes require that. Anything within 6 feet of a wet location, so if your range is within 6 feet or any other device is within 6 feet of water of any type, whether it's exterior or interior, you have to have GFI protection. So standard on like bathrooms and kitchens, those all require GFI. Exterior outlets require GFI. And the interior livable areas require arc fault. Also, garages are considered wet locations and require GFI. So just to make things simple and avoid any ambiguity in the future, I decided to get arc fault GFI combo breakers for all my primary circuits in the house. So these are actually kind of hard to find. These are QO breakers, and they are the smaller, the newer version of them. What I like about these particular breakers, you will see that there are some red flags on here. Those red flags indicate when a breaker has been tripped, and makes it real easy just to go quickly look in your panel and see which one's tripped and reset it. You'll also see a test button and a little service light. The purpose of that service light is when you do reset the breaker, it's going to tell you why it failed, which is great for diagnosing issues. So it'll tell you if it's an arc fault, GFI, or an overcurrent based upon how many flashes. So that is a really nice feature if you have a breaker that's constantly tripping for some reason, to determine whether or not there's an issue. This is one of the first jobs I actually installed the newer style. The main house has the older style. I did notice that at least one of the breakers so far did have an issue. Ended up just changing out the breaker. For some reason it was not resetting. I don't know if it was a manufacturer defect or whatever, but that's the only issue so far that I've seen with it. Other than that, I've run some power tools and things that normally would trip arc fault breakers, and I have yet to actually have any of these fail. So that's a big plus. On my main house, that was a constant issue. And at some point I will change out those breakers to the newer style and see if that solves it. Getting back on the topic of surge protection, I do have a surge protector in here, and a lot of people go, well, you got a surge protector on the outside, why do you have one on the inside? Or if you have one on the inside, why do you have one on the outside? Well, it's for two different types of surges. So you have a primary surge protector outside on the meter. That is for surges coming into the home. This one is only for surges that are coming from in your home. And you would go, well, what surges could you possibly have that are in your home? Well, as I stated before, anytime you have high amperage draw devices like shop equipment, kitchen equipment, anything that will normally cause your lights to dim on and off, that is a surge. And that is very detrimental for any electronics. So what the surge protector does is protect surges that are going between your different breakers or between your different circuits, so that one device surging is not going to cause issues with your computer in the other room or your TV that you spend thousands of dollars on. Another bonus with these surge protectors, most of the brands actually offer a warranty that is associated with protection for other devices that are in your system. And it can be tens of thousands of dollars in a warranty, which is kind of nice, and it will give you a time frame of how well that warranty is, and I don't recall what the warranty is with the surge protector is. But for a few $100 for a surge protector that takes up 2 spaces, it's a great option to just add an insurance policy on your whole electrical system. I'm not promoting them for any particular thing or any particular brand. It is just a nice peace of mind to do. Something else to think in mind is panel sizing. So you'll see I've got plenty of extra space down here. It's actually a 54 breaker panel. In the previous codes, you were only allowed up to, I believe it was a 42 or 48 panel. And when they changed the definitions for lighting loads and some other things, now you're able to actually come in to residential areas and put larger panels in. So whenever you start planning out your circuits, it's always a good idea to think about the future and add some extras. You'll also see that I've got a couple breakers in here that are not hooked up to anything. That's just for future proofing. I'm not sure what those are going to be used for yet, but I figured both just to have it in there as well as to keep everything looking nice, so I'm not going in and having all my small breakers and then large breakers and a couple small breakers for future stuff. I would just add those in now just so that I've got a couple extra circuits in case I ever decide to use them in the future. Going back to the breakers and setup, so we were talking about the neutral wires are supposed to be all up here. Well, I've got neutral wires that are going into these breakers. So on these combo breakers, they don't have a pigtail. So the older versions, way older versions, where you don't have a plug-on neutral, which is this bar down here. That is the neutral, so that actually, the neutral bonds to the breaker itself instead of having a pigtail, which is really nice and makes the box clean. And then your neutral wire just plugs right in there where it says N, and your hot wire plugs in directly below it. That is so that the circuitry in there can see the balance difference between the power going out, power coming in, and tell if it's going somewhere it's not supposed to. If you have those neutral wires back over here, that portion of the circuitry just wouldn't work. So that's why they have the neutral wire now going to the breakers instead of the neutral post over here. On some of the older versions, like I said, you would have to have a pigtail that comes off the breaker and then bond back over here. I decided because I just don't want to do the GFI protected breakers on here that I wasn't going to go through that. It just saves a lot of extra expense. Something to future-proof this so that you or anybody else that's working on the system knows what you did and what circuits are what. It's really nice to label the top portion of your wire as you're coming in. And a lot of times you'll see that electricians will just clip off the end of the wire that they've got it labeled, slide it up to the top, and then there's just a mess of different labels that are facing different directions and they're just hard to read or get to. So I put labels in 2 spots, one on the feeders coming in and then also on the hot wires prior to going into the breaker. It just makes it a lot cleaner, a lot easier to troubleshoot circuits in the future when you've forgotten or you come back to a job on where you put what, or if you're trying to open up a panel instead of referring back to your panel schedule, which I've got here nicely printed out, which is quick and easy. I mean, if you're doing a job and you know what your prints are saying, you can come up with the panel schedule ahead of time. It helps both with pre-wiring to make sure you got everything, as well as knowing how many breakers and what type of breakers prior. So there's no reason not to take a few minutes to go in and just print out your panel schedule on a sticker, stick that on the box, and just leaves a nice clean install. So again, we have 3 different reference points on what breakers are what, and this just makes it easy. So once I get the panel off, I'm not going constantly back, going over here, going, okay, well, what circuit was that? Then coming over here, counting my breakers, and troubleshooting it that way. If there's any other questions or any other topics you want me to go over, feel free to reach out to me. I am more than happy to get into more detail on how to terminate boxes and how I do my runs and different other codes. This is just a brief overview of getting the main power feed to your project and some of the more advanced things that I just don't typically see. Most residential homes, unfortunately, go with budget stuff and limit how many circuits. That's the other thing I like to do on my wiring. I like having an individual breaker for each of the rooms instead of tying them together. One of my biggest pet peeves growing up, since I was in a much older home, would be somebody trips a breaker in one room and it turns off the power in the other, and the outlets and the lights are tied into the same circuit. So not only do you lose power, but then you lose your lights. And I like to keep my outlets bonded or basically tied into a separate circuit than my lighting, so that if you do pop a breaker, you're not in the dark at the same time. It's pretty easy to think about in the future when you're wiring it up, to wire a house in that manner without without much additional cost. There is a little bit more cost in materials, but for the advantages it gives you, it is a nice feature. So again, if you'd like me to do any more videos like this, feel free to reach out. I'll be more than happy to answer any questions. Thank you.